Awesome. So I'm Sara Remsen. I'm here today actually not to talk about my startup Waypoint, but to talk about something that I find really fascinating and interesting that really informs how we think about our product development and our design. And what I want to talk about today is designing and employing the human sensor. And when we talk about augmented reality, a lot of the times we talk about the technology itself. We don't actually talk about how do we use the biological built-in technology that we already have. So like Chris said, co-founder and chief product officer of Waypoint, I have a pretty diverse background coming from business and strategy, but also the tech side and the design side. And one of the benefits of having this very liberal arts background is that I spent a lot of time standing in the forest, studying ecology. And this taught me a couple of things. And one of the things that was really interesting is that as an ecologist, you have to make connections between quantitative data that you get from sensors like temperature probes and humidity sensors, and the qualitative data of standing in the forest, looking at a monkey on a fig tree and thinking to yourself, why is that monkey on this fig tree and not that fig tree? Oh, because there's another monkey on that fig tree. And being able to make the connections between that, like those two different data modalities in a way that advances science. So what I think is so exciting about this is that we can actually use those same principles with augmented reality to have those same sort of influences. So unfortunately, this is a little bit cut off on a couple different dimensions, but this is one of my favorite comics. It says the top is a rabbit eating carrot. The bottom is all the different scientific formulas that go into this vision. And at the very bottom, it says this is how a scientist sees the world. And that is exactly how I think augmented reality can be used to help augment our space in a way that's really rich and exciting to help make those connections. So thinking about this, like this is just a stream, right? Like looks pretty basic, looks pretty boring. We have some visual information. We can see that it's water, but that's about it. And using augmented reality, we can actually make this a totally different immersive experience with all kinds of information from sensors in a way that enables humans to use our quantitative powers in addition to that sensor data. Now, why is that actually useful and as interesting as I keep saying it is? I think part of that is this idea of information in context. The right information at the right place in the right way for 4 key areas. The first is more of an enterprise application. It's similar to what Waypoint's focusing on right now, which is the day-to-day operations. So enabling a step change in terms of productivity by empowering workers with that information. The second is in education. So making sure that you can unveil a new world as that sensor data is actually integrated into your experience. The third is these rich interactions. So thinking about how do you create new interactions with the landscape and your community. And the fourth, where sort of I was coming from in the forest, is these scientific discoveries and really combining this quantitative data with the qualitative data. So this is a great image because this highlights just how good your human brain is at seeing and recognizing patterns. So we can see that there are 2 horses and 2 men in this space. And that's because we have 2 things going on. The first is that we're actually collecting like light waves, like visual cues that are going into the cones and the photoreceptors in our retinas. And the second is that our brains are wired really well to collect that type of information and parse it to make meaning. One of the things that's so exciting to me about augmented reality is not only can we take advantage of this visual sensor and this visual information of overlaying graphs and data and information, but how could we actually use different types of inputs, but use that same built-in human processor, that same human sensor? And there's some great examples of this in the animal kingdom. Again, background in biology. This is a mantis shrimp. They can see 16 different wavelengths of light. Humans can only see 3. No one knows why. They can see different 16 wavelengths. Birds, again, they can see into the UV spectrum. Sharks can actually detect electromagnetic pulses from the fish around them. These are all different inputs that we could convert into a way that our human brains can use them. Snakes can see in infrared. It just means they can detect it. It turns out that that's actually processed in the visual cortex of their brain. So we know that they are processing that as visual information. So what this leads me to is the way that we think about visual information, not just in 2D, but also in 3D. And when people depict or graph information, it looks flat. And then they bring it into 3D and they say, guess what? Let's just make our graph 3D, which really doesn't do too much. Again, what if you could actually leverage some of the ways that information is conveyed in a way that enables you to make an intuitive snap judgment. So when you look at this tree, age of a tree is based on the number of rings it has. You know automatically that this is not a 2-year-old tree. So just by looking at that immediately and having some of that information in context. Again, thinking more about the 3D aspect of things, how can you display that information spatially so that you might actually be able to see patterns or make connections that otherwise wasn't there? There's some really interesting research in synesthesia. I'm focusing mostly on the visual stuff right now, but one example is, what if you had like the stock market, like as a ticker, but like as a haptic input? So you could start to understand, like start to rewire your brain to start to find patterns or things in that data. So it's this idea of data visceralization. This is one of my favorite all-time visualizations. These are flights going over Heathrow over 24 hours. And what's so cool about this to me is that you can actually, just by looking at the motion paths, tell which types of flights these are. So you can see these really long ones are the commercial flights. These crazy ones turn out to be military training flights. And it's because, like, what is that? So just by seeing these motion paths, not just pictures, but motion paths, we can actually understand and make inferences and make connections. So, and here's a quick, some screenshots of those. So what I really want to do is take those insights and those ways that our brain works and actually bring that back out into the augmented reality space. I was lucky enough to do my thesis research here at the Media Lab with the Responsive Environments group. They have a project with Tidmarsh and Living Observatory. Tidmarsh is the first of its kind ecological wetland restoration project. It's in Plymouth, Massachusetts. They actually just became a mass Audubon site, so if you guys are looking for a fun trip, it's a really great place to go. They essentially completely restored this wetland so that it actually carried out all the functions that a good wetland carries out, which, as you know, is storm surge protection and carbon sink and a whole bunch of other things. And the Media Lab put a bunch of sensors all over the wetland to measure and understand that ecological change. And what they did was actually create a virtual representation of that data in a synthesized, resynthesized landscape across Reality Browser, where they collected these sensor nodes, and if it was raining in real life, it was now raining in the virtual world. And so what I wanted to do for my thesis is build on that sort of human sensor. How can we take this information and actually bring it back out into the field so it can be used by someone for something useful? So to step back to 9th grade biology for a second, one of the things that's really important about a wetland is its ability to process carbon. Plants are really good at that. They take carbon dioxide in, they photosynthesize, they make sugars for themselves, they put out oxygen. A fun fact about plants is that they also breathe, so they also take in oxygen just the same way that we do. They use that to run a bunch of their cellular processes, and they actually emit carbon dioxide. And that mostly happens at night. So one of the things that we wanted to see is, in this newly restored wetland, could we see more carbon being sort of sunk during the day and more carbon going out at night? How could we enable scientists and visitors and educators to actually go on site to the Tidmarsh wetland and see in real time what exactly is happening? So one of the things I did was model exactly how that works. So understanding just with sort of simple particle systems based on a bunch of different inputs that came from sensors, water, light, humidity, temperature, what that photosynthesis or cellular respiration would look like, and essentially built a tool to enable someone to really see spatially with movement what's going on. So just with one glance, you could actually see, carbon is going into the marsh, there's a lot of photosynthesis taking place. Or just with another glance, you could see, the carbon's moving really fast. There's got to be something going on here that's really influencing that. Like maybe it's really bright outside. So what this looks like, if I can make it play, is this video where you can see more of the movement. But essentially, based on this integration of sensor data, you can see exactly how the carbon is moving through the wetland at this time. And the idea here is that you could take this, put it back outside into the real world, so that you show up on site, this mass Audubon site at this wetland. You could walk up to a sensor. You could actually see what the carbon was doing at that moment just by holding up your phone, something like that. But just the scope of this project was mostly from the virtual front. So I think it's a really interesting thing to think about, all the different ways that we should actually be designing using the human sensors in mind, how we convey data, how we tell the story of information, how we enable people to make connections as quickly as possible. And that's something we should keep in mind while we are designing for augmented reality. So if you have any questions, that's my email. I'll be around. So thank you, guys.